In this presentation, we'll talk about Windows Azure Blob Storage and take a look how we implement it in the Aqua application. So Windows Azure is Microsoft's new cloud computing platform. And essentially what Azure is providing is a virtualized computing environment. This means you have up in the cloud the ability to store various types of data, run applications, have custom management, and all of this is available through a very rich developer SDK. You'll see in the lab that you build for the Aqua application, Lab 02, how you can actually store images in the blob storage in the cloud and then access it from a local application. You can do the same concept from an ASP.NET app, a WPF app, Silverlight, it really doesn't matter. All of the storage in this case is happening in the cloud, and if you desired, you could actually run entire applications in the cloud and have nothing running locally. So the Windows Azure Storage has several goals. The first is to have anywhere at any time data access. This means no matter what type of client you're using, no matter where you're at, you can point to a URI and have access to the data. You'll be able to store data for any length of time. There is no expiration. So if you think of having a database locally and having that data available whenever you need it, you would have the same concept in cloud. One of the nice things about the cloud is the ability to scale. So based on your needs, you can actually continue to scale out your data size, data structures, and processing needs on demand. You can also be confident that the data will not be lost. In the cases of Windows Azure Storage, data is actually replicated twice. So there's no chance that you would be missing or lose data in some sort of catastrophic failure. The fifth thing is pay for only what you use and store. So at this point there's been no pricing announced for Azure, but the idea behind this is that when you do have a local network with a lot of servers, you have fixed costs that you really can't change, even though you might not be using all that power. With cloud computing, you have variable pay. So based on what you're using, based on the amount of bandwidth that's being used, your pay will be different than if you had more or less. So that's the nice thing about using Azure, is that you don't have a lot of those upfront fixed costs, and then long term you should actually save money because the cost is variable and you're not spending as much to do the same amount. The horsepower is dictated. You only pay for the horsepower that you actually need. So, three concepts for storage. The first one is it's durable, scalable, and highly available. The second is you can have various types of storage concepts. So you can have blob data, which is what we use in the Aqua application. You could have normal relational tables. And then third, you can have reliable communication with queues. In order to access all of this storage, you use REST APIs, HTTP and HTTPS, or .NET APIs. So you have an option. One of the nice things about the blob storage is that there is a storage client.dll that ships with the SDK and the samples, which wraps all of the REST interface calls and allows us to interact with the cloud blob storage just as if we were interacting with a local set of tables. So it makes it very easy to access this data even though it's in the cloud. The learning curve is very minimal. Here's a little explanation on each of the different types. So blobs provide a simple interface for storing named files along with metadata. So this means that I can have containers, and inside those containers I have entities. Those entities in the case of blobs are binary large objects. Tables provide structured storage. So a table is a set of entities which contain a set of properties, and queues provide reliable storage and delivery of messages for an application. So here's a little better explanation of the blob storage concepts. So for example, in Aqua, in the account devstore account 1, which is the local account you use when you're interacting with the local instance of Azure in the development fabric, which we'll talk about a little bit later. In our account we have one or more containers. The primary container we're going to use is something called medical images. You're going to create this during the lab. And inside medical images we're going to store blob image files. So just like you would store a blob image in a field in a table in a SQL database, we're actually storing a blob image as a individual entity with properties, name value pairs, in a container in our Azure account. So these storage accounts can have many blob containers, and you'll see that in the lab. And then a container is actually a single set of blobs, or a container is a set of blobs, multiple blobs. You have sharing options, so you could say I want this to be public or private, which means if it's public, anyone that has the URI to the container and the item can view it. Otherwise, they have to be authenticated to actually view what's in the container. You can also associate metadata with containers. So those are name value pairs that you can create and apply to the blob. And you can have up to 8 KB per container. So now let's take a look at how we implement this inside of the lab. This is the Azure Blob Manager application that you're going to create in Lab 02. It's a very simple application that shows some fundamental concepts of working with Azure Blob Storage. So the first thing we'll take a look at is the properties. So what we've done here is we've used the built-in property settings for this WPF application to store configuration details that allow us to access our account with our shared key and then the URIs. So here we have an account name, dev store account 1. This is going to be the same for your local instance of Azure. So what we're doing here is we're actually running the development fabric and the development storage locally on the computer. We're not interacting with the cloud in this lab. So when you install the Windows Azure SDK, in the Start menu you have the ability to start the default development fabric and the default storage. In the storage you have set up URIs pointing to your local machine 127.0.0.1, and then you have port 1001 or 10,001, 10,002, and 10,000, which point to the various queue storage, table storage, or blob storage endpoints. Now these are essentially just used in the app config file after you store these, and then we access them through the code. So in the code you're constantly going to see instances of passing these parameters to method calls that interact with Azure. So let's take a look at blobmanager.cs. This is the main class that actually has the code which interacts with all of the Azure storage. And it's very, very simple. What's happened here is in the SDK there is a sample project called storage client, and it builds storageclient.dll. Now storageclient.dll actually has a bunch of classes that allow you to interact with Azure using REST APIs. So you don't have to go in and deal with all of the REST objects yourself in the REST calls. You can actually just call straight methods off of the object that you create and interact, as if you were interacting with any other .NET type. So it makes it very easy to work with Windows Azure Blob Storage. So you'll see here, for example, to manage blob containers, I have a method called listContainers. From my caller, it's passing in the blob endpoint, which is that URI we saw in the configuration, my account, which is dev store account 1, and then the shared key, which you saw, which is going to be the same for your local storage as well. So in listContainers, we're actually creating a storage account info object, and that storage account info object has several parameters it expects: the endpoint, the account, and the shared key. Once we have that, we'll have an object name account info, and then the second thing we're going to do is, once we have account info, pass that to, so essentially what's happening is account info is going to authenticate you and authorize you to access your Azure storage. And then we call blobstorage.create, so let's create an instance of this object, pass it the authorization info, and then return all of the blob containers. So now at this point I have a list of all the containers. Each one of those containers then has any number of blob items in it. To create a new container, just as easy, you're going to see we're always creating an account info object, and then we're going to call blobstorage.create to authorize and gain access to that object. And then in this case we call create container, and we're passing in container name, and it will go ahead and create that container inside of Azure. And then for deleting, it's very similar. We call get blob container, and we pass the container name, so we have a handle to that container object, and we call delete container. So interacting with the actual containers is very simple, and then the items within the containers is just as easy as well. So let's go down a little bit here, and we'll just show list blobs. So list blobs will return an IEnumerable. Same code as you saw before. Let's create an account info. We're going to pass in our authorization information, and then we call get blob container, pass it the container name. So for example, we have a container name called medical images. Medical images, we want to get all of the blobs that are in medical images. So we call get blob container. This will be called medical images. And then once we have a handle to that container, we call list blobs on that. And then list blobs also has some overloads and accepts some parameters. So you'll see here we have a prefix and a combined common prefixes. So in this case, the prefix will be string.empty, and since we're not passing anything, we say false. We don't want to combine anything. So you can see here that you're not actually getting involved with any REST interfaces. You're not accessing the cloud using web client system web client, because all of that is encapsulated inside of the storage client assembly. So all of those REST APIs are made easy for you. So then if we look at the user interface, which is a simple WPF application that has several options here to list containers and add images, etc. If we go ahead and look at some of this code, we're going to create some local variables, account name, shared key, and blob storage. And of course, this is what we're getting from the configuration file that we have to send every time we want to access our Azure account. So we'll go ahead and get those in initialize component. And then let's scroll down to load containers, and very simple, create a new instance of the blob manager, which is that class. We call list containers. We're passing in those 3 variables again, and then I'm going to bind that to my list box. In my list box, I have a selection changed event, and what's happening here, oops, let's close that out, we don't want to activate yet. In my selection changed event, I'm actually casting the selected item in the list box to a blob container object, and that blob container object has properties. So here I'm going to say I could do account name, base URI. I want container name. So container name is actually going to be the text that's displayed, and that's the actual container that this blob lives in. And then at that point, I want to list the blobs, and once I get that IEnumerable back, I'm going to bind that to my grid. So we're just doing some basic interactions here. We have a class that uses the REST API to work with the cloud, and then in our UI, we're just calling the methods that we've created based on events that occur within the UI. So if I go ahead and hit F5, we'll run this app, and let's go ahead and list our containers. So you can see here I have medical images, so I select medical images. Inside of my grid, I have all the medical images, so you can see it's very easy to get this data. I just bound it. If I want to add a new container, let's go ahead and add a container named test. So now there's test. I click test. So let's go ahead and add an image. Scroll down here, and let's take this nice image here. We'll click open, and that just goes ahead and it uploads it to Azure. So now this URI is actually pointing out to the cloud, HTTP 127.001/10,000/name of image.jpg, and it's just displaying it inside of the grid. So that's how easy it is to actually interact with Azure, and this is a quick overview of what you should expect in the second lab. Thanks for listening.
Infragistics. On the web at infragistics.com.